Okay. Now we will see example 3 and 4. Okay. So in this case we will consider rail system. So first two problems we discuss unit system. Right? First two problems were based on this unit system. Today's problem will be on this rail system. So those who have not drawn it, draw the rail system. Only the rail system. Okay. In this system, consider the rail system having 3 boilers and 2 generators. Right? You have 3 boilers and 2 generators. Let each set have a capacity of 60 megawatt. That means generator. So I mentioned there, generator capacity is 60 megawatt each. And the generator availability is 0.80. Generator availability is 0.80. And boiler capacity is 40 megawatt. So that means in your system it is 40, 40, 40. Generator is 60 and 60. As the availability is 0.88 for the generator, 0.91 for the boiler. Okay. Compute the probability for each state in which the boiler and the sets can reside. Okay. So we have to first find out the various states of the boiler and the generator separately. Then complete reliability model combining this both. Compute the expected output. Expected output as we discussed yesterday is capacity input work. For those who were, this is example 5, this is example 3, this is example 3, and this is example 4. Okay. So first we will calculate the boiler. How many boilers? 3 boilers. 40 each. So what can be the capacity available? 120. All up. 80. 2 up. 40. 1 up. 0. All down. Okay. So these are the 4 conditions for the boiler. So we can write here boiler available capacity. Generator, 2 generators, 60 megawatt. So either 120 megawatt is available when both are up, 60 megawatt is available when one is up, 0 megawatt is available when both are down. With this probability you can find out. How to find out? There are 3 boilers. DC 0 out. What is the outage probability?
0.0109.
0.09 to the power 0.
0.91.
91 to the power. So accordingly you can find out this. Similarly here in this case it will be 2C0, 0.12 to the power 0 and 0.88 to the power 0. Right? These are the availability for individual boiler and generator. We are calculating the rate system where we have 3 boilers and 2 generators. Okay? Evaluate this. Evaluate this for the boiler and generator separately. Evaluate. ठीक है आंसर बात. Okay.
So for boiler,
it will be here. We'll check it from here. Okay, 3 boilers up. 0.753571.
7.3 is 571.
0.753571. Then 2 boilers will be 0.22.
357.
1 boiler 0.022. 113. No boiler 0.00729. Did you get it? This is for the boiler. For the generator is 0.7742. 0.2 Barcelona 0.01. These are the cases for individual. Unit is only boiler. But our objective is to get the final overall reliability. The overall reliability is what will be so what about one capacity will be 120, but for that all 3 boilers should be up, all 2 generators should be up. That means it will be how much? 0.753571 cube. All are up, right? No, only this much. Cube ले लेगा और already अच्छा है, it's already got 3 boilers into 0.7742. So are you getting this by multiplying this? So that means this is for 3 boilers up, 2 generators up. 0.5836. Here it is 2 boilers up, 2 generators up. 2 boilers is 0.223587 into 7744. So it is this. Okay. Now 60 will be there. Either 3 boilers up, 1 generator up, or 2 boilers up and 1 generator up. Because irrespective of 3 means boiler capacity is 120, 2 means boiler capacity is 80, but generator is 60, it can run. So 60 megawatt output in this or this. That means this plus this, or either this or this. Similarly, 40 either this or this plus this. 0 megawatt, so many conditions. So this plus so many conditions. So 0 megawatt means either you have all boilers up, but generator is not up. 3 conditions are where generator is down, and 3 conditions are where all the boilers are down. So under these cases, the total capacity is 0 for this whole. Right? So what is the expected capacity? Expected capacity is, as I have told you, this will be convective. This is 120 into 0.583566 plus 80 into 0.173146 and so on. It's plus 0.020636 into 60 plus 0.002174 into 40 plus 0.01518 into 0. It is 0. So if you do this addition, you should get 97.13 megawatt. Check it. Okay. Next question. Example 5, example 3, and this is example 4. In the boiler in the previous example was rated for 60 megawatt, obtain the modified reliability model. Can you call yourself? boiler का 60 होगा हमें सेम होगा ना तीन तरफ
120 60 0
120
60 हो जाएगा
60 and generator also 120 60. What are the values for 120 or what are the probability? Generator case रहेगा generator case.
बट सर वो तो अच्छी थी ना मैंने सेटली सीरीज नंबर
Okay, ये ना सुन भाई
180 120
180 120 120 80 60 0. Yes. ये चैप्टर है बोलते हैं. Because there are 3 boilers and 2 generators. So you can obtain this. You see the solution. But this case is a bit simplified because generator output, total output can be either 120 or 60 or 0. Right? Why is so? Because 120 megawatt में either 2 boilers are, 2 generators are, or
2 boilers और 1 generator
3 boilers are, 2 generators are, or 2 boilers are, 2 generators are, or 120 megawatt. Right? There are 360 megawatt generator. So if 2 are on, that means 120 will be available. And 60 will be either 60 by 1 generator should be up,
1 generator और
or here 1 boiler should be up. Now here also
1 generator 1 boiler 1 generator
1 generator up or 1 generator up. But for the boiler case, either
2 boiler और 3 boiler 2 boiler
1 boiler to boiler.
2 boiler एक बड़ा
Okay, this case 206376 will you get from there? Here, this case. See, from here it is directly taken. Output is 60 megawatt. When either 3 boilers are up, 1 generator is up, 2 boilers are up, 1 generator is up. So that already know. The other case is 1 boiler up, 1 generator up. You find out that from here, which is, I think this two. This two will be considered because even the 2 generators are up, if 1 boiler is up, the output is 60. Right, so you add this two up. A का ही add right? 0.020, 0.02, 0.206, 0.0217. Let's see. 0.206, 0.217.
But sir, the boiler in that case is 40, but here is 60.
But it doesn't matter now. In our case, we are only concerned about outlet. This one. हम लोग को इधर है. There is no 40 case in that case. Because boiler capacity is 60. Or थोड़ा मतलब है 60 by 8 करें और 8 doesn't matter 40 doesn't matter हम लोग इधर 60 so this is the last one for generators. So now we will see what happens when we add transformers. Transformer configuration. Draw this. These are typical transformer configuration. So you can have individual transformer or shared transformer. Drawing. Okay. Consider the system in the question number 1. That means the generator single new model. Boiler generator connected. Boiler. Obtain a modified relative model in which each will be connected to an individual 60 MVA transformer having an availability of 0.4. So that means here our generating unit has one boiler, one generator. Here again one oil, one generator. There are availability already. We have calculated the last. In this case, we have already. Question number 1 is example 1. Example 1 is this in this case. So and we computed this. Okay, solution to example 1. Computed this. Then it says that on the top of that, use a 60 MVA transformer with the unavailability of 0.01. So how that will be affected? So for that system, okay, write again the those were not written, write the output. Just write this 120 megawatt at the probability 0.6412. 60 megawatt 0.31968. 0 megawatt 0.03968. So write down only the last one. So you have got in question number 1, for example 1, you have got these 3 conditions with this problem. Now it says each unit is connected to a 60 MVA transformer or 60 megawatt transformer with availability is the transformer availability is 0.80. Transformer cell is combined. That is the question. Here. Now, what was the probability for output of $120 megawatt? The probability क्या है लिख लो 0.641281. Okay, so it is not using that probably. So what it is saying is हमारा individual कितना individual का generator availability कितना 0.8 और boiler 0.9. Transformer is 0.99. Multiply this with how much will it? So it has both a roll available. Now when you consider both availability, so it will be square 0.792792 square, right? हमें from class principles आवे हम right from the very first one. So that's what it is. Directly multiply करो. So one boiler generator transformer. That availability is 0.7927. Now when you consider both 120 megawatt square, now 60 megawatt. 60 megawatt will be available over any one should be out. That means 0.2C1, 0.792792. One will be in and one will be out. Out means 1 minus effect is 1 minus this is 1 minus this is. So 1 minus 0.792792, which is written. So that comes out to be 0.32856. Right? मैंने हमें पूरा आटे को OT में कर दिया. Now when both are out, output is 0. both are out one है कितने कितने का है 1 minus 0.7927 कितना है
0.20720
0.20720
720
square this square right so which is the last case 0.0429 so this is the answer to this question first example 5 when individual second case में consider the previous question obtain the modified reliability model for two generating units shared a common 120 MVA transformer ହେଲା दीटा मिसी के जो दीटा हमर सेट हे गला दीटा मिसी की गोटे ट्रांसफॉर्मर ହେଲା so this is the case what is this this is the probability of 120 megawatt available for that system पूरा तो मैंने लिख दिया just fast पूरा तो लिख दिया whatever you wrote first right this is the one right for 120 megawatt output just now you have written 64 okay into transformer availability is 99%. So this is the case of 120 60 case है did you find out this 60 output 60 megawatt so that is how transformer availability then zero कैसे बड़ा हुआ either both generators are not available which is 0.03968 is it 0 megawatt का yes into transformer availability or transformer is available it doesn't matter whether generators are available or not transformer is not available okay this one is more complicated. Reconsider the above system. But a single 120 MVA transformer is replaced by 260 MVA transformers having the same unavailability. What in this case will be a rail system. You have a boiler and a generator. You have a boiler and a generator. But then this whole system you don't have individual transformers. Rather, you have one transformer and another transformer. Okay, so boiler, generator, boiler, generator. Okay, these are the transformers. Okay. Yes, that means they are sharing the transformer, two transformers. So it becomes a bit complicated. So, but not complicated in the sense now you can use the availability table for this that you have written already 120 60 but then for the transformer you will be making another table so let's see how it has been done but remember that each transformer is 60 MVA so both transformers should be up. So these are the output cases. So have a look at it. Have a look. Okay, so here what you see here is you are using the same values that you have in that table. Okay. From question number 1 itself. Right? This the 120, 60 and 0. But then, this time you are combining that with the transformer availability. For the first case, for 120 megawatt to be available, both the transformers should be available. That's why it is 0.99 square. For 60 megawatt, either one of the transformers should be available here. Okay. First case is either one transformer. Second case is both transformers available but one generator. 60 megawatt is the output of the system. Right? This is for 60 megawatt, right? Isn't it? Last case, 60 megawatt is available again. Any one transformer available. Here 120 megawatt is available, but any one transformer available. 60 megawatt available, both transformer available. 60 megawatt available, only one transformer is available. Okay, so therefore this is the problem. And when there will be zero probability, first case 121 megawatt available, but no transformer is available. 101 square. 60 megawatt available, but no transformer is available. 0 megawatt available, but no transformer. Okay. Therefore, this is the problem. And you will find the expected megawatt by multiplying 120 into 0.628520 plus 60 into 0.331703 plus 0 into 0.03977. So if you do that, you will get 95 megawatts. So this completes generator and transformer availability for the unit and rate systems. Okay. So next class you will see auxiliaries, availability of auxiliaries.